algebra students, and congratulations because you have made it to our last video for the class. This video is going to be a review of some of the things we have learned in this class to help you prepare better for the final. In this video, there are going to be 5 questions we look at, and these 5 questions are inspired by the most missed questions on our different unit assessments. That way, it's based off of what the majority of you guys struggled with, and hopefully will help a lot of you guys since the questions on the final will be similar. So with that, let's go ahead and get started. Our first question comes from our lesson on inequality word problems. The question says, Doris is having a car wash to raise money. They spent $54 on supplies for the car wash. They will charge each car $5 for the car wash. The first part asks, write an inequality to represent how many cars they would need to wash to make a profit. Go ahead and try that one now. Well, for this first one, some of the things they tell us that are going to impact making a profit is the $54 they spent on supplies. If you're spending $54 and you don't wash a single car, that means you lost $54. So my inequality, somewhere in it, I'm going to have my negative 54 to represent the money they're losing. Now it tells us they're going to charge each car $5 for the car wash. That $5 is money they're making. They're going to be making $5 for each car that they wash. Because it's money they're making, I'm going to make it positive, and I'm going to say this is money they lost, but they are making $5 because it's something that's happening again and again. It's $5 for every car. I need a variable in there. So I'll use C, and then off to the side, I'm just going to say that C represents the number of cars washed. So we've got you're losing $54 in the supplies, but you're making $5 for each car. And it tells us in this part here that they want to make a profit. Now, sometimes with questions similar to this, I'll say they want to make at least $100. And we would have an inequality sign like greater than or equal to $100. Or they want to make $1,000, greater than or equal to $1,000. But here it's not telling me a number. It's saying we want to make a profit. One of the things we learned in this lesson is when you say you want to make a profit, it means after you've spent your money and you've made your money, you want to be walking away with more than $0. Making a profit means you want to have greater than $0. So here in my inequality, I could finish it up by saying this is the money they have from the car wash. We want the money they have to be greater than $0. Now this is one option for your inequality. Another way you can think of it is if you are making a profit, it means the money you earn, that's an either, the money you earn is greater than the money you spend, right? If you're earning more money than you're spending, that's another way you can think of as profit. So one way is you can think it means you're making more than $0. Another way is the money you're earning is greater than the money you're spending. If you think of it this way, another inequality you could write is, well, the money we're earning is the $5 for each car. We want that to be greater than the money we spent, and we spent $54. Now this and this look different, but I want you to think, if you went to solve this, what's the first thing you would do? Well, the first thing you would do is add 54 on both sides. And if you do that, it's going to leave you with 5C is greater than 54, which is what we have written over here. For the answer to that first part of the question, I don't care which way you write it because they both say the same thing. The second part of the question says, how many cars do they need to wash to make a profit? Go ahead and try that one. Well, to answer this question, we need to solve for C. So since C is the number of cars washed, we're almost there. The last step is coming in and dividing by 5. If I want to do 54 divided by 5, I know 5 goes into 5 one time. That leaves me with a remainder of 0. If I bring down that 4, 5 goes into 4 0 times, so that still leaves me with a remainder of 4. We learned that you can get the decimal answer by putting a 0.0 there. That helps us because it gives us another number to divide with. And then we can say 5 goes into 48 times, and so we're left with 10.8. Now to answer this question, how many cars do they need to wash? We are not going to say 10.8 because we're talking about cars. You can't wash 10.8 cars. So the question with these is always, where do we want to go? Do we want to round up and say they need to wash 11 cars? Or do we want to round down and say 10 cars? Well, in this problem, remember, you're not looking at which number is closer to 10.8. You want to look at what makes sense in this problem. If you wash less cars, washing less cars means you're making less money. It means you're not going to get to that goal of making a profit. However, washing more cars means more money. That way, they'll be able to make their profit. So for this one here, how many cars do they need to wash? We're going to round up, and we're going to say 11 cars. Now, part of what we're doing right now is reviewing for your final. I want to talk about how you could check this. What could we have done to confirm that 11 cars is our answer? Well, we could check by going up and doing the math. Forget all the algebra you did. If you go up here, how much money are you going to make if you wash 11 cars? Well, 11 cars, $5 each car. That means you're making $55. You spent $54 on the supplies. So that means you are walking away with a profit of $1, which maybe isn't a good profit, but it's a profit. If we had gone down to 10 cars, if you only wash 10 cars, $5 a car is a total of $50. That's not going to cover the money you spent on supplies. If you only wash 10 cars, you're losing money. So you could do that. You could come back up to the story. You could use your inequality here to confirm that if I put 11 cars for C, that I'm making more than $0. However you think of it, but make sure, especially for these word problems, you can check these on your final by going back up to the story and making sure your answer makes sense. This was the first review question we're looking at. Our second one is also related to inequalities. The second one comes from the lesson on compounds inequalities. There are, again, 2 parts to this question. It says solve and graph that compound inequality. Let's start off by having you just solve it. Solve that compound inequality. Like I had mentioned at the beginning of this video, this is inspired by the most missed questions, and I think solving compound inequalities was one of the most missed questions. So I want to make sure I do a good job reviewing how you solve these. Normally, for just a not compound inequality, if you have something like this, remember your goal is to get your variable by itself. Some people like drawing lines at their inequalities. If I had an inequality like that, I would want to add 2 on both sides and then divide by the -3. That would help me get the r by itself. Even though it's a compound inequality, we're still going to do those same steps. The difference is with compound inequalities like this one, there are 3 parts to the inequality. So if I'm looking here in the middle, I find my r right here, and I say, okay, I've got to get rid of that -2 first to get r by itself. In order to get rid of a -2, we're doing the opposite. I'm adding 2. All of that's the same. The only difference is we want to add 2 for all 3 sides. I'm going to add 2 here, I'm going to add 2 here, and I'm going to add 2 here. When we do that, that leaves us with 6 is less than -3r, which is less than or equal to 12. That's our first step. Now remember, again, our goal is to get the variable, here it's r, all by itself. So in this problem, we still have that -3 there, so I need to finish solving by dividing by -3. Now, same as before, whatever we're doing here in the middle, we need to do on all 3 sides. So if I'm dividing by -3 here, I'm going to divide by -3 here, and I'm also going to divide by -3 here. When I do that, in the middle, -3 divided by -3 gives me 1. 1r is the same thing as r, so those -3's cancel out. On my left side, 6 divided by -3 is -2. And then over here on my right side, 12 divided by -3 is -4. Now, the one rule we learned with solving inequalities is if you divide or multiply by a negative number, that inequality sign is going to change. So instead of a less than sign, here I'm going to change it. I'm going to switch it around and say greater than, and then here it'll be greater than or equal to. So right now I've got -2 is greater than r, which is greater than or equal to -4. One of the mistakes I saw students make was that they wanted to keep going. They wanted to get rid of the -4 or get rid of the -2 or do something else. This is a compound inequality, and one of the compound inequalities we learned looks like this. What this is saying is that r, if I cover it up here, r is less than -2, and r is greater than or equal to -4. What this is really saying is that r is in between -2 and -4. I'm going to write that down. This right here is our final answer because it is saying r is between -2 and -4. If your variable is all by itself, we're done solving. There's nothing else we need to do here. That inequality right there is telling me that r is going to be any number between these two. See how it's physically in between -2 and -4? That's what it's saying, is r is any number between those. The second part is graphing. It really helps if you look at this and can say to yourself, okay, that's saying r is between -2 and -4, because it's going to help you know what the graph looks like. Go ahead, I know you can't graph on the video, but go ahead and describe what the graph would look like for this problem. The first thing I like to do is I like to go in and put my circles. We learned that if it does not have an or equal to sign, it is an open circle. So I need an open circle at -2. And then here, because it is or equal to, I'm going to have a closed circle at -4. And I mentioned earlier, it really helps if you look at that and say to yourself, that is saying r is between -2 and -4, because that's what we need to show here on our number line. Our number line, what we're graphing right now, is showing all the numbers r can be. So I'm going to show that r can be any number between -2 and -4 by shading in between -2 and -4. So that's showing that r can be -3. But also remember there's decimals and fractions between those. So r could be like -3.3 or -3.5. There are all those numbers in between -2 and -4. This was one of the compound inequalities we learned. The other one we learned was the or inequalities. Remember, or was when you had like two inequalities. We could say like r is greater than -2 or r is less than -4, and we had the two arrows. Those questions weren't missed as much. It was really these fun looking ones here. You know it's an and inequality like this when you see two inequality signs in the same problem. That's a clue that it's going to solve like this. I hope this problem here was helpful if you are one of the students struggling a little bit more with compound inequalities. We'll go ahead and erase this and we'll move on to the next question. Our next one comes from our lesson on writing linear equations. I've got two questions for this topic. We are going to write an equation of this graph, and then we are going to write an equation using this information here. Before we look at either of them, don't look yet. Before we look at either of them, I want to review the formulas we learned with writing linear equations. There was two formulas we used. One formula was y equals mx plus b. This formula here we called slope-intercept form. In this formula, m represented your slope and b represented your y-intercepts. The other one we learned was y minus y1 equals m times x minus x1. In this formula, which is called point slope form, there's a spot for a point, that was the x1, y1, and then there was a spot for your slope, which again was m. Normally when students take the final, these are formulas we give to you when you take the final. We give them to you on a piece of paper. So feel free to write these down near your desk, your bed, your kitchen table, wherever you're working, and keep them handy for the test because you don't need to memorize these, but you do need to know how to use them. So here they are. They're given to you here. Go ahead and use possibly one of these to help you write an equation of that graph. If I wanted to write an equation of this line right here, I need to ask myself which one is going to be more helpful. If I'm using this formula, I need to know slope and y-intercept. So if I wanted to use that for this one, I need to be able to look at it and see what's the slope, what's the y-intercept. If I want to use this one here, I need slope and a point. Looking at a graph here, this formula is going to be more helpful because we can look at it and easily find our slope and a y-intercept and be done with it. It's not to say you couldn't use this. You could pick a point somewhere on your line and then label the coordinate and then substitute it in, but there's going to be more steps with that option. So I'm going to use my y equals mx plus b for this first one here. When you are looking at this line, we said there's two things you need. You need your slope and you need your y-intercept. I'm going to start with that y-intercept. Y-intercepts are the points where it crosses your line on the y-axis. Here, this line is crossing our y-axis at this point here, which is the point 4. So that tells me my y-intercept is going to be plus 4. Now my slope, in order to find slope from a graph, we are going to use, we're going to use rise over run. And when I look at the graph, I'm going to need a second point. I've got one point, but I need another point to count to so I can count the rise and the run. Now when you're picking points on your line, I don't want to pick a point like this. See how that's, maybe you can't, maybe it's too far away, but it's in between the grid lines. I want to pick a point that clearly intersects those grid lines at a specific point because we're going to be counting boxes with our rise over run. So if I follow the line, I see that this point right here clearly intersects on the graph. It's very clear that that point right there is at the point 4, 1. Now that I've got my 2 points, I can count my rise over run. My rise is 1, 2, 3, and my run is 1, 2, 3, 4. So we get 3 over 4. Now there's something I missed. Here, notice how I counted down 3. If you are counting down to get to the next point, you're going to want that to be negative. One of the biggest mistakes students make when they're finding slope from a graph is with the sign. Notice if your line is going down from left to right. If it's going down, that'll mean a negative slope. If our line had looked like this, so if that line was going up from left to right, that would be a positive slope. Always, always, always. Once you have your slope is negative 3/4, all you have to do is substitute that into our equation. So we've got y equals my slope negative 3/4. Don't forget about your x. So we get the equation y equals negative 3/4 x plus 4. That's our equation for this first one here, the graph. Now the second question over here says write an equation of a line that has a slope of negative 1/2 and goes through the point 4, negative 10. Go ahead and try that one now. All right. If I wanted to write an equation using this information, I notice that I have slope and I have a point. If you have point and slope, you want to use point slope form, which was y minus y1 equals m times x minus x1. Here, I could not use y equals mx plus b. Why could I not use that? Well, in order to use that, I need to know my y-intercept they didn't give me a y-intercept. I don't know what number it's crossing on my y-axis. I don't know what that point is. Instead, I just know a different point. So because I don't know the y-intercept, I can't use that formula, which is fine because we've got this one. If I want to use point-slope form to help me write my equation, I've got my slope, which I'm going to substitute for m, and then my point here, which I'm going to substitute for x1, y1. Labeling helps get them all in the right spot. I've got y minus y1, which is negative 10. Make sure you've got both negative signs there. That'll be important. And then our slope is negative 1/2 times x minus x1, which is our 4 there. The last part of this is just changing this to be in slope-intercept form. Oftentimes, this is not going to be an answer option. Instead, they're all going to be y equals mx plus b using that form. So here, one of the first things I noticed is I got 2 minus signs. That is the same thing as adding 10. So I'm going to go ahead and change it to that. And then over here, I'm going to start by distributing my negative 1/2. That'll give me negative 1/2 x. And then negative 1/2 times negative 4. Well, negative times negative, I'll start with that. That's going to give me a positive. 1/2 times 4. You could always multiply 1/2 times 4 over 1 like that. But multiplying by 1/2 is pretty easy because it's just taking half of that number. So half of 4 is 2. My last part, if I want y all by itself for y equals mx plus b, I need to get rid of my plus 10 by subtracting 10 on both sides. When I do that, that'll leave me with y equals, which is what I was looking for. Y equals negative 1/2 x, and then 2 minus 10 gives me minus 8. Once it's in slope-intercept form, I can see that my slope is negative 1/2, which I already knew. They told me that. But now I can see that the y-intercept is minus 8. That's why we couldn't use slope-intercept form, because nowhere in this problem was I told that the y-intercept was negative 8. So there was nothing I knew at this point that I could substitute for b. Hopefully this is a good review of writing linear equations and the 2 formulas we use to write linear equations. I'll go ahead and erase all this and we'll keep moving right along. The next question is also related to linear equations. This lesson comes from our lesson on horizontal and vertical lines. The question is, what is the difference between the equations below? Graph each. So you can leave the graphing to me, but if you want to describe the difference between these 3 equations, go ahead and try that now. I'm going to start off with these first 2 equations here. We've got x equals negative 2 and y equals negative 2. One of the biggest differences between these and all the other linear equations we've looked at is each of these only has one variable, which is a sign that it's going to be a horizontal or vertical line. The biggest mistake I saw students making on the unit assessment, where I gave a similar question to this, was getting them backwards. If the equation says x equals, what that means is that the line is going to intersect your x-axis. Not that it goes the same way as the x-axis, but that it crosses through your x-axis. Specifically, it crosses through your x-axis at negative 2. What I would want to do in order to graph that is on my x-axis, find negative 2, which is going to be on this side, 1, 2, right there. And remember we said it's intersecting your x-axis. It's going to cross through our x-axis, which means it is a vertical line. Any point you pick on this line is going to have an x-coordinate of negative 2. Now for the y equals negative 2, that's the opposite. Instead of intersecting our x-axis, it's going to intersect our y-axis at negative 2. So that one right there would be a horizontal line. It would be a line that looks like this one here. Since this one starts off with a y equals, I can compare that to slope-intercept form. Remember, that might be too late. Remember the formula we were just looking at a moment ago. If I compare it to y equals mx plus b, I see the y equals. I don't see an x, but I've got that minus 2. That's telling me that the y-intercept is negative 2, which it is. And then since our x is missing, it's a 0 there. Our slope is 0. And this horizontal line here has a slope of 0. It's not rising at all, but it's running. So it's rising 0 over some sort of run. Now this last one here, y equals negative 2x, is different from the other two because it's not a horizontal or vertical line. This has both variables. Again, I think it's helpful if you compare it to y equals mx plus b. Unlike the other two, this one has an actual slope. It's got a slope of negative 2, and then the y-intercept is missing, which means the y-intercept must be 0, just like over here when the slope was missing. So if I wanted to graph this one here, I would start at 0. If you're looking for a vocabulary word to use, that's called your origin. I'm starting at my origin. My slope is negative 2. You think of it with rise over run. That's rising a negative 2, run 1. So I'm going to go down 2 over 1. And we end up with a diagonal line like this. If you wanted to compare these three, there's lots of different things you can say. At a minimum, I would say that the first one is a vertical line, the second one is a horizontal line, and the third one is a diagonal line. That's what a line is if it's not horizontal or vertical. If you wanted to continue to compare, one of the things you could say for this last one is that the y-intercept here is 0. The y-intercept here is negative 2, and then this one doesn't have a y-intercept. It has an x-intercept. You could say for each of these, it's only intersecting one of your axes. Here, it's only intersecting our y-axis. Here, it's only intersecting our x-axis. This one intersects both. There's a lot of different comparisons you can do there, but I want to make sure that you know the difference between these two. Because like I said, I think that was the biggest mistake students were making on the assessment. Hopefully you find this helpful. We have got one last question. I made the last one a fun one. In my opinion, fun. Look at this last one. So in this last one, we are going to review a bunch of stuff you guys learned with polynomials, which was this last unit we looked at. In this problem, I've got a couple steps we're going to follow. The first step is begin with 4x minus 7. So that's going to be what you're starting with. You are going to multiply it by 2x plus 3, get a result, then subtract 5x to the 4th power plus 2x squared minus 5x minus 21, get a result, and then divide by 2x. Go ahead and try this yourself first. Go through all 4 steps, and then we'll look at it together. I think you are a polynomial pro if you're able to go through all of this and get the correct answer. Go ahead and try it now. All right, so the first thing we wanted to do is we're going to begin with 4x minus 7, and they're telling us to multiply by 2x plus 3. If I write that out, I've got 4x minus 7 that I'm starting with, and I'm putting parentheses around it because I'm going to multiply everything I'm starting with by 2x plus 3. So it's going to start off by being one of these binomial multiplication problems. When I go to multiply, we thought of it as like distributing twice. I'm going to start off by distributing my 4x to 2x and to the 3. And then afterwards, I'll distribute that at negative 7. So to start, 4x times 2x. Well, 4 times 2 gives me 8. And x times x gives me x squared. Next, 4x times 3. Well, 4 times 3 gives me 12, and I need to copy down my x. And then we're going to go again. So next, I'm going to take my minus 7 and distribute it to 2x and to 3. When I do that, I've got negative 7 times 2x. That's negative 14x. And then the negative 7 times 3 gives me negative 21. So I've got 4 terms right now. Something you always want to check to see if you can do is, can you simplify? Here in this problem, I'll grab another color. I can simplify by combining the 12x minus 14x. When I do that, this 8x squared stays the same, but 12 minus 14 gives me negative 2. So I get negative 2x from those two middle terms, and then minus 21. So that is the result after this first problem. If you don't have this, that's fine. If you want to pause the video and see if you can finish it up, go ahead and try that. But we're going to keep moving right along. So we've got this as my answer for step 2. The next thing we want to do is subtract. We want to subtract 5x to the 4th power plus 2x squared minus 5x minus 21. Similarly to up here, I want to subtract this entire polynomial. So when I write it out, I'm going to put, here's my first polynomial, minus 2x minus 21. But I want to subtract this entire polynomial. And the way you show that I want to subtract this entire polynomial is with more parentheses, just like up here. So I want to subtract 5x to the 4th power plus 2x squared minus 5x minus 21. Now those parentheses are important because when we go to actually do the math, one of the first things you're going to do is distribute that subtraction sign. So what it's going to look like is if I want to subtract this polynomial, I'm subtracting 5x to the 4th power, but I am also subtracting 2x squared. I am also subtracting negative 5x, which is the same thing as adding 5x. You can think of a negative times a negative gives you positive. And then I am subtracting a negative 21, which is the same thing as adding 21. That first polynomial there is going to stay the same. So it's still 8x squared minus 2x minus 21. Now, goodness, I've got a lot of terms here. Just like before, I want to check to see, can I simplify? One of the things I see that are like terms is our 8x squared minus 2x squared. It seems like every marker I grab is dead. When I go to do 8x squared minus 2x squared, well, the 8 minus 2 gives me 6. So we get 6x squared. That was me using these two. One of the strategies we talked about in our adding and subtracting polynomial lesson is when you've got a ton of terms like this that you're combining, cross them out as you use them. That way you won't miss any. So I've used those two. I'm looking for more things to combine. I see a minus 2x plus 5x. So I'm going to go there next. Negative 2 plus 5. I'm going to subtract, keep it positive. That leaves me with plus 3x. Looking for other things to combine, I see a minus 21 and a positive 21. Negative 21 plus 21 is 0. The word we use a lot is those cancel. And that would leave me with nothing, so there's nothing for me to write down. This is why I cross stuff out, because something like that, I might think I've used everything, but I see there is a minus 5x to the 4th power there that I still need to bring down. There's nothing for me to combine it with. One of the things we talked about with polynomials is we like having them in what's called descending order. So you start with the biggest exponent and go smaller. So I'm going to bring this down, but I'm going to bring it down to the front since it has the largest exponent. And then put a plus sign there since that 6 was positive. I'm a little out of breath. So we're left with negative 5x to the 4th power plus 6x squared plus 3x. Now there was one last step. That last step says divide by 2x. Same as before, if you did not get this after step 3, it's okay. Pause the video now, see if you can fix your mistake. If not, let's figure out what the final answer is to this. I want to divide by 2x. The theme of all of this is I'm looking at a polynomial. If I want to divide by 2x, it means I want to divide all of this by 2x. So there's those parentheses again. You can write it like that, or I'm going to write it over here. You could write it as that polynomial all divided by 2x. However you think it, what you're going to have to do is divide each of these terms by 2x. So let's start with the first term, negative 5x to the 4th power divided by 2x. Well, the first thing I'm going to look at are those coefficients, those numbers. Negative 5 divided by 2, I can't do that. You could write your answer with a decimal, or what I think is the easiest is if you can't divide it, just keep it as a fraction. Just keep negative 5 over 2. So my answer, I'm going to start off with a negative 5 halves. When I go to divide my variable, we learned the exponent rule for division is if you're dividing things, subtract your exponents. So I want to do 4 minus 1 to get my final exponent, and that would be x cubed. I've divided this one. Next comes the 6x squared. 6x squared divided by 2x. Well, 6 divided by 2 is easier than before. That's a 3. And then x squared divided by x. If you're using that exponent rule again, that's 2 minus 1. That leaves us with x. X to the 1st power, which is just x. I've done that. Now for this last one, I've got 3x divided by 2x. Well, 3 divided by 2, like before, that is a fraction. So I'm going to write 3 over 2. X divided by x, be careful. If I'm dividing the same thing, those cancel out and leave me with 1. If you're using the exponent rule, 1 minus 1 gives you x to the 0 power. And we also learned in our unit that x to the 0 power is the same thing as 1. So I don't need any x's in that last term. This would be the final answer for this problem. Like I said at the very beginning of this problem, if you got through all 4 of those steps and you got this as your final answer, you are a polynomial pro. If you did not get this as your final answer, but you figured out your mistakes as you were going through it, awesome job too. Remember, this is just a review video and we're focusing in on some of the things that students found more challenging. So hopefully this gave you an opportunity to review all that stuff we learned about polynomials. This is also the last review question for this video, so you've made it to the end. There's no more videos for me to watch for this class. If there was something you really feel like you struggled with in this class that we did not review in this video, please reach out to me or Denise and we will be happy to help give you some extra support before you take that final. If not though, and you're feeling awesome about the final, I wish you the best of luck with it, and I'll see you guys later. Bye.